Hello everyone. In this video we are going to solve the problem number 1.35 from Irodov, and that is related to kinematics. So let us first read out the problem and then we will solve the problem step by step. A particle moves in the plane xy with the velocity v is equal to ai cap plus bx j cap, where I cap and j cap are the unit vectors of the x and y axis and a and b are constants. At the initial moment of time, the particle was located at the point x is equal to y is equal to 0, and it is asking to find the equation of particle's trajectory. So let us say this is x direction and this is y direction. This particular point is the origin, that is 0, 0, which is the initial point of the particle at time instant of t is equal to t is equal to 0. Let us say at the time instant of t is equal to t, the velocity of the particle is given as ai cap plus bx j cap, where I and j cap are the unit vectors along x and y direction respectively, and a and b are constants. Okay, now we can write the expression of velocity is equal to vx, that is velocity in the x direction I cap, plus vy, that is velocity in the y direction, into j cap. Okay, so here vx is equal to a and vy is equal to b into x. We can write vx is equal to dx by dt is equal to a, and we can write vy is equal to dy by dt is equal to bx. So let us first solve this particular equation, then we will move on to this particular equation. So let us say we can write dx by dt is equal to a, and let's take dt to this particular side, so we can get dx is equal to a times dt. Now let us integrate both the sides from t is equal to 0. At the time instant of t is equal to 0, the x position was x is equal to 0, and at the time instant of t, let us say at this position x. So from here we will get the integration of 1 is x, so we can write x from x is equal to 0 to x is equal to a times integration of 1 is t from t is equal to 0 to t. So from here we will get x is equal to a times t. Okay, now coming to the second equation. In the second equation it is given that dy by dt is equal to b into x. Now here we are having the derivative of y with respect to time, but on the right hand side we have the function of x. So we cannot integrate this particular function, so for that we have to convert from x to t. So let us write it as b times x is equal to at, that we have found out here. So let us substitute here, so we can write b times at. So we can write dy by dt is equal to ab into t. Let us take dt to this particular side, so we can write dy is equal to abt into dt integral. Okay, again it is starting from t is equal to 0, and at that particular time instant y is equal to 0 because it was at origin, and at the time instant of t, let us say it was at y. Okay, now let us integrate both the sides. We will get y from y is equal to 0 to y is equal to ab times the integration of t is t square by 2. So we can write t square by 2 from t is equal to 0 to t. So from here we will get y is equal to ab times t square by 2. So this is the function of y in terms of t we have got, and we also got the x as a function of time. But in the first problem it is asking to find the equation of particle's trajectory, that is y as a function of x. For that we will eliminate t from both these expressions. So let us eliminate t from both the expression. We can write t is equal to x upon a from this expression, and we can substitute in this equation. So we can write y is equal to ab divided by t, and we can write t as x divided by a whole square. So we will get y is equal to ab by 2 into x square by a square. So from here we will get y is equal to b upon 2a into x square. So we can see this is the motion of the particle we have got, that is the trajectory equation, where we have got y as a function of x. Okay. Now let us come to the second problem, in which it is asking to find the curvature radius of trajectory as a function of x. So let us come to the B part, where it is asking to find the curvature radius of the trajectory as a function of x. So we know that the radius of curvature equation is r is equal to 1 plus dy by dx whole square to the power of 3 by 2 whole divided by d square y divided by dx square. Okay. So the function here is simple, so we can differentiate this particular function. So we can write dy by dx is equal to b upon 2a is constant and d by dx of x square. So we can write b by 2a, and the differentiation of x square is 2x, so we can write bx upon a. And again, if we differentiate twice, then we can write d square y by dx square is equal to d by dx of dy by dx, that is equal to d by dx of bx upon a. So we can write the differentiation of x is 1 and the b by a is constant, so we can write b by a. Let us substitute the value of dy by dx and d square y upon dx square. So we can write r is equal to 1 plus dy by dx is bx upon a. So we can write bx upon a whole square to the power 3 by 2 divided by b by a. So from here we can write 1 plus b square x square by a square to the power 3 by 2 whole divided by b by a. Okay. Let us further simplify this. So we will get a square plus b square x square whole divided by a square to the power 3 by 2 divided by b by a. So from here we can write a square plus b square x square to the power 3 by 2 whole divided by b by a into a cube. So we can write finally a square plus b square x square to the power 3 by 2 whole divided by b into a square. This is the value of radius of curvature we have got as a function of x. Now this you can remember in order to find the radius of curvature. So I think we have solve the equations. Okay. So I hope the entire procedure is clear. Thank you.